We are now going to look at the nomenclature of the alkane. What do we call nomenclature? Nomenclature is the naming of the compound. And for you to name alkane groups, there are about 8 or 9 rules that you should know. Any one of the rules that is not understood, you cannot name the compound. Now, I will not waste time in writing sentences here. I will explain, I will write the theorems or the rules with demonstration. Rule number 1 is you count the number of carbon atoms in the longest continuous chain. If I go fast, you replay the video again. Rule number 1 is you count the number of carbon atoms in the longest continuous chain. Count the number of carbon atoms in the longest continuous chain. What do I mean by that? By demonstration. Rule 1 will be represented this way. If that is how we have represented a structure, this happens to be the representation. Let us say there is another branch here. When you now want to count the number of carbon atoms in the longest continuous chain, there are 3 branches here. One of the branches is when you go direct. The other way is when you move from here, the moment you reach at this point, there is a branch, you come down. The other one is when you move from this end, the moment you reach here, you come this way. So those are the 3 branches here. We now count, among the 3 branches I have just indicated, we now count the number that will give us the highest number of carbon atoms. If you consider the first one, the arrow at the top, you have 1, 2, 3, 4, 5, 6, 7 carbon atoms. If you consider the other one this way, 1, 2, 3, 4 carbon atoms. If you consider this way, you have 1, 2, 3, 4, 5, 6 carbon atoms. So the one that will give us the highest number of carbon atoms is the one on top. So when you are doing that, you always count the number of carbon atoms in the longest continuous chain, the one that will give you the highest one. Rule number 2. You number the longest continuous chain starting from the end very close to the branching. You number the longest continuous chain starting from the end very close to the branching. That will be demonstrated here. Let us now say the longest continuous chain is 1, 2, 3, 4, 5, 6 here. If you take it this way, 1, 2, 3, 4, 5. If you take it this way, 1, 2, 3, 4. So the longest continuous chain becomes 1, 2, 3, 4, 5, 6. If this happens to be the longest continuous chain, any other substituent carbon you see is a branch. Therefore, this one is a branch because it is part of the main chain. It's a branch. So we now look at the end that is very close to this branching. You consider this end 1, 2, 3 before you see the branch. You see here 1, 2, 3, 4 before you see the branch. So we have the right to say this branch is very close to this end because 1, 2, 3, you see the branch. So this branch is very close to this end than this other end. Therefore, we start the numbering from this end. 1, 2, 3, 4, 5, 6. That is how the numbering goes because at this end, this particular end, the branching is very close to this end than that other end. Rule number 3. You use the number at which the branch is attached to name the compound. Use the number at which the branch is attached to name the compound. In this case, the branch here is attached at number 3. So when we are naming that compound, we use number 3. Because the branch is at number 3. That is what rule number 3 states. From rule number 3, it takes us to rule number 4. Rule number 4 is now dealing with the branches. How are branches named? That anytime you have one carbon atom with 3 hydrogen atoms on the branch, the name becomes methyl. That becomes methyl. We are looking at rule number 4. Anytime you see 2 carbon atoms with 5 hydrogen atoms, the name becomes ethyl. Anytime you see 3 carbon atoms with 7 hydrogen atoms, become propyl. The list continues with C4H9. C4H9 becomes butyl, etc., etc. So the branches are named using this format. When you see in a branch that it is 1 carbon atom with 3 hydrogen atoms, you say methyl. That is what rule number 4 states. Now, if that is the case, we go to rule number 5. Rule number 5 says halogens are named as follows. That means how to name halogens, group 7 elements. When you see Cl, it is no more chlorine but chloro. When you see Br, it is no more bromine but bromo. When you see I, it is no more iodine but iodo. And F becomes fluoro. Those are the basic rule in naming that one. From that one, we go to rule number 6. We go to rule number 6 in the naming. And rule number 6 says when two different branches are present, you name them alphabetically. When two different branches are present, you name them alphabetically. We represent that here. When you look at this structure, you have 1, 2, 3, 4, 5, 6. This can be the longest continuous chain. Because when you take it this way, 1, 2, 3, 4. You take it this way, 1, 2, 3, 4, 5. So the longest continuous chain is when you go this way. Any other one now that is attached is a branch. So that means when we now consider this thing, this particular branch here is very close to this end. 1, 2, 3. You see the branch. If you take it this way, 1, 2, 3, 4. So this branch is very close to this end than this other end. The numbering starts from here. 1, 2, 3, 4, 5, 6. Now, one rule says you use the number at which the branch is attached to name the compound. Let us now identify the branches that are here. One of the branches is one carbon atom here. We have one carbon atom with 1, 2, 3 hydrogen atoms. And when that happens, the name is methyl. The other branch here is Br, and Br is bromo. The rule now here says when two different branches, methyl and bromo, these are two different branches. So when two different branches are present, you name them alphabetically. Therefore, B comes before M. Whatever name you want to do, the compound with B comes first before you consider M. So as a result of that, we name bromine first before we go to the methane. Therefore, bromine is at number 4. It becomes 4-bromo. 4-bromo. Before we look at the methyl. The methyl is at number 3. It becomes 3. Is at number 3. 3-methyl because of 1 carbon atom and 3 hydrogen atoms. 3-methyl. And we have 6 of them hexane from yesterday. So that will be the way that structure is named. That is rule number 6. We now go to rule number 7. Rule number 7 says that similar branches are named using some prefixes. Similar branches, when you want to name them, use prefixes. When two similar branches are used, two similar branches, when they are present, two similar branches, when they are used, you use the word di for them. When 3 similar branches are present, use tri for them. When 4 similar branches are present, you use tetra for them, etc., etc. The list continues. So that is how that rule is practicalized. Anytime you have 2 similar, that means they are the same. 2 of them, you use di for them. You see 3 of them, you use tri. You see 4 of them, you use tetra. We now go to rule number 8. Rule number 8 now says where similar branches are present on the same carbon atom, use the number twice. Where similar branches are present on the same carbon atom, we use the number twice. That means we use that number 2 times. Let us demonstrate that. We are considering this to be the longest continuous chain. 1, 2, 3, 4, 5, 6. That happens to be the longest continuous chain. If it is the longest continuous chain, any other one you see attached is a branch. Therefore, this one here is a branch. This again is a branch. But when you see these 2 branches, this one is 1 carbon atom here with 1, 2, 3 hydrogen atoms. This one again is 1 carbon atom with 1, 2, 3 hydrogen atoms. So they are similar, they are the same. Now these branches are very close to this end. This branch is very close to this end than this other end. So we start the numbering from this end. 1, 2, 3, 4, 5, 6. Now there are similar branches, but they are on the same carbon atom. This and this, they are similar on the same carbon atom. They are on carbon number 2. So we use the number twice. Since there are 2 of them, but they are similar, we use the number where they are attached 2 times. This and this, they are now attached at number 2. We say 2, 2. 2, 2 because they are 2 similar when both of them are the same. 2, 2, When two similar branches are present, we go to this rule. For two similar branches, we use die. So it becomes 2, 2, die. But any one of these two branches, this and this is CH3, and CH3 is methyl. So 2, 2, die, methyl, and we have 6 of them, 1, 2, 3, 4, 5, 6. Hexane. Hexane. That is how that rule is represented. We go to the last but not the least. That is rule number 8. Rule number 8 is the last but not the... Rule number 9 is the last but not the least rule. What does rule number 9 says? That when branches are present at equal ends with another branch in between, you use a number that gives the lower point of contact. When branches are at equal end with another branch in between, you use a number that gives the lower point of contact. We'll represent that again here. So let us say there is a branch here, CL. Let us say there is a branch CL. Now, when you look at this compound, this particular structure here, we try as much as possible to represent it this way. We see 1, 2, you see a branch. 1, 2, there is a branch. 1, 2, there is also a branch here. So therefore, they are at equal ends. Both of them are at equal ends. 1, 2, there is a branch. 1, 2, there is a branch. But there is another one in between these two branches. So anytime you have branches at equal end, 1, 2, you see a branch. 1, 2, you see a branch with another one in between. There are two ways you can write the numbers. Because this branch is very close to this end, we have the right to start the number this way. 1, 2, 3, 4, 5, 6, 7. This other one will also not agree because it is very close to the end, also on the second part. So we also have the right to start the number this way. 1, 2, 3, 4, 5, 6, 7. Now we consider the numbers that are at the top, where the branches are attached. Numbers that are at the top numbers. Let us now look at the numbers that are at the top, where the branches are attached. Now this branch, the number that is at the top for this branch is number 2. This one, the number that is at the top here. These are the numbers at the top, these are the ones down. So for this branch, the number that is at the top here is 2. For this branch, this CL branch, the number at the top is 3. For this other branch, the number that is at the top is 6. So if I add 2 plus 3 plus 6, I will get a total of 11. 2 plus 3 plus 6, that will give me a total of 11. We go to bottom numbers. Bottom numbers. The numbers that are at the bottom, where the branches are attached, are, for this one at the bottom, these are the numbers. This one is at number 6. This one is at number 3. This is a branch. The number that is representing down is number 3. This one is a branch. The number below it is at 2. So if that is the case, when you add this one, 6 plus 3 here becomes 9 plus 2 becomes 11. So if that is the case, you can use any of the numbers to name it. You can use any of the numbers to name that compound. Now let us say this compound was shifted a bit. Let us say this one was shifted a bit. But that one will be discussed now in the other class tomorrow.